Welcome to lecture number 109 of digital electronics. In this lecture we are going to deal with ripple counters. Now in lecture number 108 we have dealt with 2-bit ripple up down counter using positive edge triggering, and dealt with positive edge triggering circuit, and so here we have used positive edge triggering. Now coming into design of negative edge trigger circuits, we have designed 2-bit ripple up counter as well as 2-bit ripple down counter using negative edge trigger flip-flops. Now in this lecture, that is in lecture number 109, we are going to deal with negative edge triggered up down counter. That is, we are having a 3-bit, so I am going for 3-bit here, 3-bit ripple negative edge triggered up bar down counter. Okay. So already it is a ripple counter, so it is known as asynchronous counter. Already it is mentioned that it is ripple, so it is asynchronous mode. Now anyway, it is 3-bit negative edge triggered up down counter. Okay, so there should be a mode selector between up and down. That means here I am taking, if m is equal to 1, I am going for up count, and if m is equal to 0, I am going for down count. Okay, so this is the mode selector. So the mode selector, that is m is equal to 1, I am going for up counter, and m is equal to 0, I am going for down counter. That is the mode selector. Now since this is 3-bit, and again all the flip-flops in the synchronous circuit should work in toggle mode, so I am taking T flip-flop. So I am hereby taking T flip-flop and drawing the circuit. Okay. So I am having T1, Q1 bar, T2, Q2 bar, T3, Q3 bar. Now let us go into the up count concept. If it is up count concept, and if it is negative edge triggered, Q1 is directly connected to the clock of second flip-flop. Okay. So here I should have a mode selector. Okay. If I am having an M here, you should AND Q1 with M. Okay, that is for up count. And if M is bar, that is if M is equal to 0, you should do it with Q1 bar. So here I am going to AND it with Q1 bar, and I am ORing that too. I am ORing these two and giving us clock to flip-flop number 2. So here I am having negative edge triggered clock here. Okay. Now the same is being repeated. That is, here Q2. I need to repeat Q2 here. So Q2 I should multiply by I should do it by M. Yeah. Now Q2 bar I should go with M bar. I should go with M bar, and then I should OR that too. I should OR that too and give it to T3. Okay, and my outputs are Q1, Q2 and Q3. These three are my outputs. Now let me check what happens when m is equal to 1. Say this is clock 1, clock 2 and clock 3. Okay. Now the expression of clock 2 is given as, you will get m Q1, so that is you will get m Q1 which is negative edge trigger, that is you will get M Q1 or M bar Q1 bar or M bar Q1 bar. Now what is clock 3? Clock 3 will be M Q2 or M bar Q2 bar. Okay. Now let us explain the working when M is equal to 1. See, when M is equal to 1, what happens to clock 2? When M is equal to 1, what is clock 2? Clock 2 becomes what? When M is equal to 1, clock 2 becomes M. Clock 2 becomes Q1, right? And clock 3 becomes Q2. Okay. Now when M is equal to 0, what happens? When M is equal to 0, what happens? Clock 2 becomes Q1 bar. Clock 2 becomes Q1 bar. And clock 3 becomes Q2 bar. Okay, that is the only difference here. Now let us go for negative edge triggering. Okay, so initially I am assuming that my Q1, Q2 and Q3 is 0. That is my initial condition. Okay, now let me go with that. So I am having a clock. So clock I am giving, which is negative edge triggering, 2, 3, 4, 5, 6, 7, 8, 9. I'm going with 9. Okay. Now this is the clock. This is a clock applied to flip-flop number 1. That is clock of T1. Now again I am going for negative edge triggering. So I should take these edges. Negative edge triggering means when transition of the clock happens from 1 to 0. So I should take these edges. So I am taking that. I'm taking that edges here. Okay. Now coming back. Initially what happens? Initially Q1, Q2 and Q3 are 0. So we are having Q1 is 0 up to this point. This is 0. Q2 is also 0 up to this point, and Q3 is also 0 up to that point. Now here what happens? When the clock comes, Q1 will become 1. And in the next clock Q1 will become 0. Right? Since this is toggle flip-flop, so this is 0, 1, 0. So this is 1. Again it comes back to 0. At this point it will come back to 1, 0, 1, 0, like that it will go. Okay, that means Q1 will become 0 to 1 when it is triggered. Now I am considering the case when M is equal to 1. When M is equal to 1, what happens? Q1 is the clock for Q2. That means you should go with the negative edge of Q1. You should go with the negative edge of Q1. That means here also it will be 0. So here we will get 1, and 1 will remain up to this point. And here it will become 0 up to this point. So we have 0, 0 here. And here we will get 1. 1 will remain up to this point. And at this point it will become 0. Okay. So that is Q2. Now what is Q3? Yeah, that is Q1, Q2. Now what is Q3? That means Q3 means the clock is Q2. Q3 means the clock is Q2. That means clock 3 that you will get it as Q2. That is the clock. That is why when M is equal to 1. Okay. So here what happens? So here Q2 is acting as a clock for Q3. So here it is negative edge trigger. So you need to consider only these 2 points. So up till this point it will have the value 0, and at this point it will become 1, and it will become 0 only at this point. Okay, this 1, 1, 1, 1, it will come back to 0 at this point, like that it will go. So this is 0. Now let me check what is actually happening here. Okay. So I am writing in the order Q3, Q2, Q1. I am writing the outputs in this order and writing the decimal equivalents. Initially Q3, Q2, Q1, everything is equal to 0. In the next clockwise, what happens? You will get 0, 0, 1. 0, 0, 1. Then you will get 0, 1, 0. 0, 1, 0. Then what you have? 0, 1, 1. 0, 1, 1. Then in the next clockwise, what you have? 1, 0, 0. 1, 0, 0. Then what you have? 1, 0, 1. 1, 0, 1. In the next clockwise, what you have? 1, 1, 0. 1, 1, 0. In the next clockwise, what you have? 1, 1, 1. 1, 1, 1. And in the next clockwise, what you have? It becomes 0, 0, 0. 0, 0, 0. That means if you are writing the decimal equivalents, you will get it as 0, 0, 0. That is 0, 1, 2, 3, 4, 5, 6, 7. Again back to 0. So this is basically what. So if you are writing the state diagram, you will get 0, then 1, 2, 3, 4, 5, 6, 7 and go into 0. This is when m is equal to 1. When m is equal to 1, it acts as up counter. When m is equal to 1, it acts as up counter. Okay. Hope you got the operation of up counting operation. Now coming into down counting operation. Now I am going for m is equal to 0. When m is equal to 0, what is the clock? Clock 2 is Q1 bar. Clock 2 is Q1 bar. And clock 3 is Q2 bar. Right? Clock 1 is Q1 bar and clock 3 is Q2 bar. Right. Okay. Now again it is negative edge triggered. So I am drawing the clock. 1, 2, 3, 4, 5, 6, 7, 8, 9. I am drawing 9 clocks. Okay. So this is input to T1. Okay. That is a clock of T1. Since that is negative edge triggered, I should mark these points. Negative edge triggered. I should mark these points. Okay. And take it down. It is basically negative edge triggered. So I should go for these points. Yeah. Now assume that initially Q1, Q2, Q3 is equal to 0. Initially I am assuming that Q1 and Q1, Q2, Q3 is equal to 0. So Q1, yeah, I should take Q1, Q2, Q3. Everything is 0. Q1 is 0, Q2 is 0 and Q3 everything is 0. So 0, 0, 0. Now since Q1 bar is a clock for Q2, I should draw Q1 bar also. So Q1 bar I am taking here as 1. And Q2 bar is a clock for Q3. So I should draw Q2 bar also. I should draw Q2 bar. Q2 bar is 1. Now all the flip-flops are in toggle mode. So here what happens? At this point it will be, the output of flip-flop number 1 will become 1. At this point it will become 0. This is becoming 1 up to here. 1, 0, 1, 0, 1, 0, 1 and it will go like that. Now if that is the case of Q1, how will be Q1 bar? It will be exact complement of Q1. So we will get 1, 0, 1, 0, 1, 0, 1, 0, 1, 0. Like that it will go. Now what is the clock of flip-flop number 2? Clock of flip-flop number 2 is Q1 bar. And again it is negative edge triggered. So you should take these points. 1, 2, 3, 4, 5. You should take negative edge triggering points. So at this point Q2 becomes 1. Q2 will remain 1 up till here. So we have 1, 1. And here up till here it will remain as 0. It is negative edge triggered. And at this point it will become 1 up to this point. So we get 1, 1. and again it will roll back to 0 up to this point, and at this point it will go to 1. So that is Q2. Now what is Q2 bar? Q2 bar is exact complement of Q2. So we get 0, 1, it will come to 0, 0, and then it will come to 1, 1. At this point it will go to 0, 0. At this point it will come to 1, 1. And at this point you will get just 0. Now what is Q3? For getting Q3, Q2 bar is the clock, and you should check for negative edge triggered. So at this point it will be triggered, and again it is triggering at this point and this point. So 0 will remain here, and at this point it will become 1, and 1 will remain up to this point. Up to this point, that means it is negative edge triggered. That is after the next negative edge trigger, it will remain as 1, and up to next negative edge triggering, it will remain as 0, and at this point it will change to 1. Now I am writing in Q3, Q2, Q1 order. So initially what is Q3, Q2, Q1? 0, 0, 0, 0, 0, 0. Then what do we get? 1, 1, 1. 1, 1, 1 in the next clock. Then what do you have? 1, 1, 0, 1, 1, 0. Then what do you have? 1, 0, 1, 1, 0, 1, 1, 0, 1, that is there. Then comes 1, 0, 0, 1, 0, 0. Then comes 0, 1, 1, 0, 1, 1. Then comes 0, 1, 0, 1, 0, 0, 1, 0. Yeah. Then comes 0, 0, 1, 0. So we'll get 2. Then what happens? 0, 0, 1, 0, 0, 1. Then what do we get? 0, 0, 0, 0, 0, 0. And then it will go to 1, 1, 1. Like that it will go. Okay. And if you are writing the decimal equivalence, what will it be? It will be 0, 7, 6, 5, 4, 3, 2, 1, 0. Again back to 7. Okay. So this is basically what? This is basically down count. So this is basically down counting. Okay. So now I have explained about up counting and down counting. Okay. So here I have explained a 3-bit ripple up down counter. So I have mentioned with the example of a 3-bit ripple up down counter. Okay. Now coming into once more explanation of that. So here when m is equal to 1, it acts as up count, and when mod m is equal to 1, it acts as up count, and when mod m is equal to 0, it acts as down count. So we have derived clock 2 and clock 3 for that. Okay, clock 2 is mq1 or m bar q1. That means if m is equal to 1, q1 will be the clock of flip-flop number 2, and q2 will be the clock of flip-flop number 3. So this is taken as flip-flop number 1. This is flip-flop number 2, and this is flip-flop number 3. And of course here toggle is t is equal to 1 and t3 is equal to 1. Please don't forget that. And with the help of the timing diagram, this is the case when m is equal to 1. Okay, with the help of timing diagram, when m is equal to 1, we have proved that it is up counting here, and when m is equal to 0, with the help of timing diagram, we have proved that it is down count. Okay, so that is regarding 3-bit ripple negative edge triggered up down counter. Okay, and okay, so that is regarding this lecture. And in the next lecture, we will be dealing with modulus counters. That means mod 10 counter or mod 7 counter or mod 5 counter. How you can design such kind of counters using this asynchronous concept. Thank you.